All right, today we're diving into something called PaperBanana. It's a new AI framework from the minds at Google and Peking University, and it's built to tackle one of the biggest headaches for any scientist, making really good visuals for their research papers.
You ever think about this? It's kind of a paradox, right? We have AI that can sift through tons of literature, write complex code, but when it comes to visually explaining a breakthrough idea, even the smartest researchers can hit a wall. Making those clear, professional-looking visuals for a publication is a huge bottleneck, and it actually slows down how fast we can all learn from each other.
And I'm not exaggerating here. This is a real problem. It's a super labor-intensive process that can literally delay getting critical research out there, all because translating a brilliant concept into a simple, clear diagram, it's just, well, it's really, really hard.
So, what's the big idea with PaperBanana? Well, instead of just throwing one giant AI model at the problem, the researchers got clever. They built an automated system that basically works like its own little specialized design agency, one that's custom-built for academic papers. Now, this is the key thing to understand. PaperBanana isn't just a single AI. It's what's called an agentic framework. The best way to think about it is like a whole team of little specialized AIs, all collaborating and working together to turn that dense, technical text into a polished, professional illustration.
So how does this 5-agent dream team actually get the job done? Let's break down the whole process.
It all happens in two main phases. First, there's the linear planning stage, which is all about laying the groundwork and getting a solid plan in place. Then, it kicks into the second phase, iterative refinement. This is basically a quality control loop that goes around and around. And separating it like this is so smart. It stops the AI from just rushing to a final design, making sure the end result is not only good-looking, but also scientifically spot on.
Okay, so let's meet the crew. Think of them like a creative project team. First up, you've got the retriever. It's the researcher hunting down about 10 different examples to get the style just right. Then, the planner acts as the project manager, taking all that technical jargon and writing up a clear, simple brief. After that, the stylist comes in, playing the role of art director to make sure the design has that specific NeurIPS look. The visualizer is your hands-on designer, the one actually creating the diagram or, as we'll see, writing the code for plots. And finally, you have the critic, who is maybe the most important member. This is your meticulous proofreader, inspecting everything for errors and sending it back for 3 full rounds of revisions until it's absolutely perfect.
So a collaborative AI crew sounds pretty cool in theory, but does it actually perform? To figure that out, the researchers set up a really tough test, a benchmark using 292 real-world examples from past publications at the top-tier NeurIPS conference.
And yeah, the results are pretty striking. PaperBanana didn't just win, it beat the baseline models on every single metric. Just look at that, a massive 37.2% jump in conciseness. That means it makes diagrams that are just way clearer. But the real headline here is that 17% boost to the overall score. That's a huge deal.
Let's just focus on that overall score for a second. A 17% improvement is a massive leap forward. This score isn't just one thing. It's a combo of clarity, aesthetics, and accuracy. It really proves that this multi-agent team approach produces results that are just tangibly, measurably better than what a single AI can do on its own.
Okay, impressive scores are one thing, but for my money, the absolute cleverest part of PaperBanana is how it deals with statistical plots. You know, the kind of charts where every single number has to be perfectly 100% accurate. See, here's the problem. If you ask a standard AI image generator to make a bar chart, it might create something that looks totally plausible, but the numbers could be completely wrong. This is what researchers call numerical hallucinations, and for a scientific paper, that is an absolute deal breaker. You just can't have that. So PaperBanana's solution is brilliant. It makes a critical switch. Instead of telling the AI to draw a plot, it tells it to write Python code using a library called matplotlib. Now, the direct image might look a little slicker sometimes, but the coding approach, it guarantees 100% data fidelity. It just completely solves the hallucination problem, period.
And this quote from the paper really just nails it. This hybrid approach, using AI image models for the illustrative diagrams, but then switching to executable code for the data-driven plots, that's the core innovation. It ensures you get creativity when you need it and absolute precision where it matters most. And get this, the system is also smart enough to adapt its style. It actually understands that different fields of science have their own unique visual languages. So if it's working on a paper about AI agents, it knows to go for a friendlier, more illustrative vibe with robots and chat bubbles. But for something on computer vision, it switches to dense, geometric shapes like camera cones.
That ability to tailor the output shows a really incredible level of understanding.
So let's pull all this together. What does a tool like PaperBanana really mean for the future of research? I mean, why should we care so much about an AI that just makes better diagrams?
So just to recap the highlights, you've got a 5-agent team that automates these complex visuals. It uses a smart 2-phase process for quality control. It delivers a solid 17% performance boost over the competition, and, critically, it uses Python code to get 100% accuracy on data plots. It's just a really elegant solution to a very real problem.
And that really brings us to the final, big-picture thought. You see, tools like PaperBanana aren't just about saving a bit of time. They're about augmenting human intellect. By taking over the tedious, difficult work of visual communication, it frees up brilliant researchers to focus on what they do best, making the next big discovery. So the real question is, what new frontiers is that going to unlock?